So, in this, we are covering common mode rejection ratio, and these are followed by the standard notes of Ramakant Gaikwad, the famous author of linear integrated circuits. So, these notes can be used and be applied to university levels also. Okay, so we will cover common mode rejection ratio.
Common mode rejection ratio. Definition it is a measure of a device ability to reject the signal common to both the positive and negative device input. Okay, when a common signal is applied to both the positive and negative device input, then common mode rejection ratio means the ability to reject it, to cancel it off. Okay, because generally it is the noise. This is not the signal amplification but the electromagnetic interference and other transistor relevant of the ICs that come into picture. So it has to reject that noise signal. That ability is known as common mode rejection ratio, and it should be generally very high. Okay, now let us go for the explanation. In op-amp we had two types of gain: differential gain and common mode gain. Okay, differential gain, the circuit is this one. Okay, the same circuit, plus and minus, and the positive input is given to V1 and negative input is given to V2. The V1 polarity is plus upside and negative downwards. V2 is minus polarity upside and plus downwards. Both are taking VID by 2 and VID by 2. Only the polarities are different matching. Okay. So when we see a op-amp is a differential amplifier and it amplifies the difference between the two input. Okay. Now what is the difference between the two input? VID. VID is equal to V1 minus V2. That is V1 minus V2. V1 is equal to VID by 2. Okay. And minus, then comes minus, and then V2 is equal to minus VID by 2 because the minus polarity comes upside. So when this gets added, then it becomes twice VID by 2, and then we reject it cancelled off, and VID is equal to VID. Okay. Now what is AD? AD is the differential gain. Okay, differential gain, which is the important, which is the signal gain, which is we are relevant with AD. Okay, so we want AD to be nice and more. Okay, signal gain should be more rather than noise signal. Okay, so that differential gain is known as AD, signal gain or differential gain. AD is equal to VOD by VID, and VOD is the output differential gain. VO is the output and VID is the input, which is the differential input, VID. Okay, so VID is the input voltage difference and VOD is the output difference. Okay, output VOD we consider as VOD output. So AD is equal to output by input, that is VOD by VID, and that actually an ideal case should be infinity. Okay, ideally differential gain should be infinity. Okay, this is because VID should be 0, but VID never becomes 0, it has a small difference. So now we go for common mode gain. As we are going for differential gain, now we will check about common mode gain. In common mode gain, same signal is given at both input, that is VICM. Okay, same is gain. Here also VICM comes, here also VICM. So VICM means voltage input common mode. Here in this case, op-amp is a differential amplifier and it amplifies the difference between the input signal. Okay, the difference between these two. But the difference between these two is 0. VICM is equal to VICM. So difference is equal to 0. Since difference is equal to 0, ideally output voltage should be equal to 0 because see it amplifies the difference. Difference itself is 0, then output would be 0. But it is not the case. We will check out this one. See, but actually there is a voltage, common mode voltage at the output. Since op-amp are built with transistors within IC, transistors are not equal in characteristics, they differ. So due to these imperfections, we get the output common mode voltage. Okay, so common mode gain is equal to ACM. ACM is equal to VOCM by VICM. VOCM is the output common mode and VIC is the input common mode voltage. We can see in this one. Here see, VOCM is the output and VICM is the input. Okay, this is the input. So common mode gain. So common mode gain is same as the VOCM by VICM. Now common mode rejection ratio is the ratio of differential gain by common mode gain. Okay, and ideally it should be infinity, AD by ACM. In 741 IC, CMMRR is equal to 90 decibels typically. That we have to remember. CMMRR is 90 decibels for 741 IC. CMR real formula is equal to 20 log 10 into AD by ACM. Okay. Actual representation of op-amp including both common mode and differential mode below, it is shown below here. So if that was separately shown, common mode and differential, here we will integrate both to show how it looks like. So see, this is the VID2 plus minus, and this is the minus VID by 2. These two are the voltages which are given to the input terminal. So difference of this is equal to VID is equal to VID by 2 minus VID by 2. So it becomes VID. Okay, so differential is equal to VID. So and this is the common mode noise signal which is given to both the terminals. Okay, we coming to both. This is the noise signal, common mode noise signal. It comes due to electromagnetic interference also, 50 Hz signal. Okay, so we have to reduce this signal. So V0 is equal to V0 output is equal to AD VID. AD is the differential gain into VID plus ACM. ACM is equal to common mode gain into VICM. Okay, so generally this should be low, but if it exceeds, then there will be a problem in the differential real signal gain. Okay, so that's why CMR should always be high. CMMR should always be high. It will be high only when a common mode gain becomes closer to 0, right? So that is the thing. CMRR should always be high. So this is what we have learned in common mode rejection ratio. It should always be high so that it eliminates the noise signal that comes and we get the real signal at the output. Okay, so this is the definition as I said. It is the measure of a device ability to reject the signal common to both the positive and negative device input. So that was common mode rejection ratio. Hope you understood it. Next we'll cover many other topics and many other parameters. Thanks.